this book to make sure that you just watch the initial part of this video, and then once I start doing questions, try to do them on your own first for the best results, and then come back for explanations as needed. But I'm going to do a quick little summary of some things that you should remember before doing this chapter. So for the first thing, you need to know a couple of formulas and the asymptote rules. So I would check back into chapter 4 and chapter 44, the videos for those before pursuing these problems. Also, just as a reminder, x and y intercept, we plug in 0 for the opposite. So if you're finding x-intercept, plug in the 0 for the y. If you're finding y-intercept, plug in 0 for the x. And then this chapter is mostly just on functions and plugging in the inputs and getting the outputs, things like that. So we'll just do a little example first before we get started. So let's say that f of x, oops, let me just get this centered. Let's say that f of x is equal to x squared minus 1. And they want you to find out what f of 2 is. Well, you see how the x is replacing the 2 right here? So you would do the same thing where 2 just replaces the x in the equation every time. So it becomes 2 squared minus 1. That's all that that's saying. So then it would be 4 minus 1, and you would get 3. So that's like a basic example of these types of problems. Now, sometimes you'll have something that looks like this, where they say find f of g of x. And then let's say that in this case, g of x was, I don't know, let's say x plus 1. So then what you would do is if they want you to find f of g of 2, for instance, you would plug in 2 into this formula. You would get 3, and then you're really just finding f of 3. So then you plug in the 3 is now the x in this formula. So it becomes 3 squared minus 1, or 9 minus 1, and that would equal 8. So those are just a few reminders. And then also you might see something that looks a little strange to you that you might not be used to, where they make something look like this, where there's actually 2 numbers in the parentheses. So it might be something like f of 1 comma 2, something like that. And then they have an equation where you can plug in an x and a y. All you're doing for that is it's the same concept as these. It's just that the 1 would be the x that you're plugging in, the 2 would be the y. And then for inverse functions, you just switch the x and the y and solve for the new y. And we'll be doing some examples of those. So then for number 1, it says, what are the y-coordinates, or what are the coordinates of the y-intercept of the graph of the function shown below? So remember, if you're finding y-intercept, you plug in 0 for the opposite, 0 for x. So then that's going to be anything to the 0 power is 1, and then we subtract 2. Thanks for the likes, guys. And then 1 minus 2 is just negative 1, so that means our y-intercept is negative 1. Our x is 0, so it would be 0 comma negative 1, or D in this case. So let's go to number 2. It says Arthur is working with a particular function. When he puts the value 3 into the function, the output is negative 10. So input and output. Input is just the x, basically, and output is the f of x. So this is saying when x is 3, when he inputs 3, the output is negative 10. So f of x is negative 10 in that case. And then for the second sentence, it says, when I put in the, when he puts the value of negative 2 into the function, the output is 40. So this is saying, hey, when x is negative 2, for f of x, we're going to get 40. So which of these equations does that? Like when you put in 3, do you get negative 10? So let's test them out. So when we put in 3 here, we get negative 30 plus 20. That does give us negative 10, so that works, but you have to check both. So then let's plug in negative 2 here. So negative 10 times negative 2 is going to be positive 20, plus 20 is going to be 40, so that one works for both, so it would be F. Thank you guys for liking and sharing the live. And then let's go to number 3. So this one is one of those kind of funky ones that people mess up on, and just start inside out, basically. So start with the inside part, the g of negative 3, find that. So we want to just focus on g of negative 3. So negative 3 is replacing the x here. So it has to replace the x in the equation as well. So it's going to be negative 3 cubed minus 1. So that's going to be negative 27 minus 1. So that's going to be equal to negative 28. So g of negative 3 is equal to negative 28. So we can replace all of this with negative 28. So we can say we're finding f of negative 28 now. That's why I always say, like, work inside out is like something I repeat to myself and to my students when they're doing this. And then what we're going to do is now that the negative 28 is replacing the x in the f of x equation. So everywhere we see an x here, we're going to put in negative 28. So it's going to be 5 times negative 28 plus 2. So then when we do that, that's going to be negative 138. So then that would be A. Okay, so let's go to, someone said they're getting flashbacks. I'm sorry to traumatize you. Okay, so then let's go to number 4. If f of x is equal to this for all the numbers, then which of the following is equal to the inverse? So this is one of those inverse ones. These are very rare on the exam. You didn't add the 2. So this you can do in like in a calculator if you can't do it in your head. You just do like 5 times negative 28 plus 2. That's going to be negative 138. So then let's go to the next one, which is number 4. So then it would be f of negative 1, inverse of, we're basically finding the inverse function. So to find the inverse function, what I like to do is I like to rewrite the original function and say like this is equal to y is equal to 2x squared, because f of x is the same thing as saying y, essentially. They just wrote it a different way. And then what you do to find the inverse is you just flip where x and y are. So instead of y being there, you put an x there, and instead of x being here, you put a y there, and then you solve for y, and that's the inverse. So you're going to have x over 2 is equal to y squared. Then you're going to square root each side to get y by itself. So you're going to have x, so the square root of x over 2 is equal to y. Thank you for the roses. And then that's going to be k. This is for ACT, for the person that asked. But a lot of this applies to SAT as well. If I were to take it at age 28 and get a great score, does that still get me scholarships? I'm actually not sure about that. I am a college consultant, but I don't work with like graduate students or like older students. It's always been kids in high school that are going to college. So I'm not quite sure. So let's go to number 5. For the function shown below, at what value of x is f of x undefined? So undefined, I like to think about it as it's impossible. So what is impossible in this situation? Well, it would be impossible to have a 0 as a denominator. So that's when it would be undefined, when this denominator, the bottom, equals 0. So if I subtract 4 from each side, I'm going to get x is equal to negative 4. That's when it's impossible or undefined. So it's going to be E. Thank you for liking and sharing the live, guys. So then let's go to number 6. The linear function f is defined as, let me just move this really quick. The linear function f is defined by f of x is equal to that. What is the value of f of 5? So you see here, they're just replacing the x with a 5. So you do the same thing in the equation. Replace everywhere you see an x with a 5. So it's going to be 2 times 5 minus 3. So then that's going to be equal to 2 times 2, which is equal to 4. So it would be G. Okay, so let's keep going. How long are you tutoring for this? Because are you tutoring for this because I think of retaking this in the fall as a senior? So today's live, I'm going to do like just this section. It's 29 questions, and then I might come back at 4. Sorry, my dog is not well behaved. Chloe, stop. And then, so, oh my God, sorry. I'm on a live right now. Okay, so I'm going to be tutoring for just like, I don't know, this probably like is 30 more minutes, and then I'm going to come back around 4 p.m. Eastern time probably. So then I'm going to go to the next part, number 7. If f is a function defined by this, then f of 3, 2 is, so you're going to replace everywhere you see an x with a 3, and everywhere you see a y, you're going to replace it with a 2. So then it's going to be equal to 5 times 3 squared minus 6 times 2. So then that's going to be equal to 5 times 9, which is 45, minus 12. So when you do 45 minus 12, that's going to be 33, right there. So then let's go to number 8. So it says if f of x is equal to that, then f of 3 plus b is equal to... Hold on, let me get my dog to come in here so she stops barking. Chloe Garcia, come here. Chloe. Come on, Elvis. Come on. Elvis. Come on. Okay. Sorry, guys. Okay, so let's go to the next part. So it says that we have, for number 8, f of x is equal to that, and then we're trying to find f of 3 plus b. So we have to plug in 3 plus b for x. So everywhere I see an x, I'm plugging in 3 plus b. Now 3 plus b squared is just this. So now what we're going to do is FOIL this. Remember that foiling means that we have to multiply each of these following the acronym. So we have to do the first things multiplied, which is 3 times 3, which is 9, and then we have to do the b times 3 and b times 3. Hold on, sorry. My dog is just, okay, are you good? Okay. So then we're going to do 3b plus 3b, which is 6b, plus b squared, and then plus 12 plus 4b, because we're doing distributive property there, and then subtract the 5. So now we're going to combine like terms. So then we have b squared, and then we're going to combine the 6b plus 4b, which is 10b. Then we have to do 9 plus 12, which is 21, minus 5, which is going to be 16. So then it's going to be g. So then we have to go and do number 9. So it says we are trying to find f of x minus a minus f of x. So let's start with finding what f of x minus a is. So f of x minus a just means instead of an x, we're plugging in x minus a everywhere we see x. So I'm going to say 3 times x minus a minus 2. Thanks for liking and sharing the live, guys. And then we're going to do distributive property, and then combine like terms after. So it's going to be 3x minus 3a minus 2. And then we're going to now do like subtracting the f of x part. So we have all of this. We have f of x minus a, 3x minus 3a minus 2. And we're going to subtract all of f of x. We're going to subtract 3x minus 2 because I'm subtracting all of it. So that minus sign has to be applied to each of these. So if I distribute that minus sign, it's going to be negative 3x plus 2. Now, negative 3x and 3x cancel out, negative 2 and positive 2 cancel out, and then I get negative 3a, which is b. So then let's go to, someone asked if I do GED practice. I do not on this channel. I kind of focus on SAT and ACT stuff, but a lot of it crosses over, so it'll still help you. Number 10, it says the line y equals this intersects the parabola right here at 2 comma k. If a is a constant, what is the value of k? So when stuff intersects, it means that they're equal to each other at a certain value or a certain point. So you could say that the y's are equal to each other, so you could set these equations equal to each other. So you could say 3x plus a is equal to x squared plus ax plus 4. Now they gave you a point that they intersect, so they're equal to each other when the x is 2 and when the y is k. So let's plug in 2 for x here to find out what a is, because that'll help us solve for what y is. So we're going to say, okay, 2 is our x. And when we plug in 2 for x, we get this. And now I'm just going to simplify and solve for a. So I get 3 times 2 is 6, so 6 plus a is equal to 2 squared is 4, plus 2a plus 4. Now I have to combine my like terms, so then I get 6 plus a on the left, and 4 plus 4 is 8, so it's 2a plus 8. So now I'm going to subtract a from each side. So that's going to make it cancel out on the left-hand side and just leave us with that 6. And then on the right-hand side, we get a plus 8. Now I'm going to subtract 8 from each side. And I'm going to get negative 2 is equal to a. So now I know that a is not just a, it's negative 2. But that's not what we're solving for. We're trying to find k. This is going to help us do that, though. So now we have an equation that says y is equal to 3x plus negative 2. Well, my y in this case is k, so I can replace that with k. So then if I rewrite it down here, it would be k is equal to 3x minus 2. And then remember, we know what the x is. We know it's 2. So we could plug in 2 for x. And then we could say that this is 6 minus 2, which is equal to 4. So it would be j. Thank you guys for liking and sharing the live. So then let's go to this next one, number 11. It says, for number 11, it says that if x cannot equal 0 and f of x equals this, and f of negative 1 is equal to 7, then which of the following equations could be used to find a? So the negative 1 is replacing the x here, and then the whole thing is equal to 7. So the f of x is 7. So we're going to say 7 is equal to, when we plug in negative 1 for x, so negative 1 plus a over negative 1 cubed. So now I'm going to say 7 is equal to negative 1 plus a over negative 1 cubed is just negative 1. So now I can divide each of these terms by negative 1. I could say 7 is equal to negative 1 divided by negative 1 is positive 1. And then positive a divided by negative 1 is just negative a. So 7 is equal to 1 minus a. But you might notice it doesn't look like that over here. They actually rewrote it, or I rewrote it because I wrote this, so that it was negative a plus 1, because that's the same exact thing as saying 1 minus a. So it would be C. So then let's go to number 12. What is the value of f of 9 minus f of 6? So f of 9 is going to be equal to 9 cubed, because we're just plugging in a 9 for x. And then how is C1? I don't know what you mean by C1. So then what we're going to do is we're going to plug in 9 for x, everywhere we see x, to find out what f of 9 is. So then when we do 9 cubed, that's going to be 729 plus 2 times 8, or 2 times 9 is 18, and then minus 15. So when we solve that out, we're going to get 732. Does this include trig? Not for the live we're doing right now, but the book does, yes. So then now we're going to find f of 6, and then once we have that, we could subtract the 2. So f of 6 just means I'm going to be plugging in a 6 everywhere we see the that there's an x. So plus 2 times 6 minus 15. So then 6 cubed, that's going to be 216, plus 2 times 6 is 12, minus 15. So when we solve this all out, we get 213. Now remember, they want f of 9 minus f of 6. Well, f of 9 we found was 732, so we're doing 732 minus f of 6, which is 213, we said. So then if we subtract these, we would get 519, which is G. This is ACT math for people asking, but this will also help you with the SAT and other stuff too. So then let's go now to number 13. So number 13, we have this table right here. And can I use a calculator? Yes, we can use you can use a calculator on the ACT. What is the value of f of g of 0? So start inside out. So let's first find g of 0. So g, when x is 0, is going to be negative 2. So we're really being asked about f at negative 2. So now let's find f when x is negative 2. When x is negative 2, f is 4. So that equals 4. So it would be E. I'm glad you guys are enjoying the live. And if you need any books for SAT or ACT prep, please consider my books, because they're, I mean, I'm biased, but I honestly believe they're the best ones out there. That's why I wrote it, so that my students had better materials. They're available on Amazon. So then if f of k is equal to 6, then what is the value of g of k? So f of k is equal to 6. So they're saying that f of some value of x, which they're calling k in this instance, has to equal 6. So 6 has to be equal to, sorry, I got distracted. So then 6 is going to have negative 1 as the x, or in this case, like the k is what we're calling it. So we have k is equal to negative 1, because that's the value of x, or k, that gives us 6 as our f of x. So now we're going to be doing g at negative 1. So if we go to where g is, when x is equal to negative 1, that's going to be 3. So it would be j. Would your book be helpful for preparing for the SAT in only 20 days? Yes, actually. Let me show you something really quick. That's also, it says on the back, perfect for cramming and mastering SAT math. Because how the book works is you go and the chapter 1 has like study plans. So it's like if you are cramming, meaning you have like a week or less, do this. If you have about a month, do this. So yes, it's like it's made for that. It's made for doing that, or if you have 2+ more months. And it tells you exactly what to do so that you can study as efficiently as possible. So let me go back to what we were doing. Oh wait, there's some questions. This is for ACT math, this one that we're doing today. Okay, so then let's go to, why is the question K but the table is X? Because sometimes they'll put a different variable to like try to trick you, but it really means the same thing. Like whatever's in the parentheses is representing your X. So then, which of the following are not true? So we have f of g of 3. So let's find out what that is. So g of 3 is going to be g when the x is 3, so 1. So it's going to be the f at 1. F when x is 1 is going to be 5. So this is saying 5 is equal to the negative of f of 0 plus g of 0. Yes, I do help with geometry for the person that asked. We'll be doing some of those another time. This will also help with the military exams, yes. So then f of 0, f when x is 0 is negative 3, and g when x is 0 is going to be negative 2. So negative 3 plus negative 2. So then it's saying that 5 is equal to the negative of negative 5, because negative 3 plus negative 2 is negative 5. So 5 is equal to 5. That is true, but we're looking for what's not true. So it can't be that one. So now we're going to be looking at f of negative 1 over g of 2. Let's see what that is. So f when x is negative 1 is going to be 6. So 6 over g of 2. G when x is 2 is 6. Is equal to the value of a when g of a equals 4. So when does g equal 4? G equals 4 when x is 1. And x is the same thing as a in this scenario. So a is equal to 1. And this is equal to 1. So they are in fact equal. Remember, we're finding what's not true, so it can't be that one. So then let's go to C. So it says g of 2 minus f of 2. So g of 2, g when x is 2 is 6. Minus f of 2, so f when x is 2 is going to be 7, over negative 1 equals g at 3. So g when x is 3 is 1. So that's going to be 6 minus 7 is negative 1, divided by negative 1 is positive 1. That does equal positive 1. So then that's true. We want what's not true, so we cross that out. Now let's find f of g of negative 1. So g of negative 1, g when x is negative 1 is 3. So for this one, we're finding f at 3. So f when x is 3 is 0. So that's saying 0 is equal to 3 plus g at negative 1. G when x is negative 1 is going to be 3. So 0 does not equal 3 plus 3, so it's D. It is D for everyone that said that. The most you can get is a 1600 for someone asking on the SAT. On the ACT, it's a 36. So then let's go to the next one. Thanks for liking and sharing the live, guys. Which of the following statements must be true? So we're going to say, so this time it's what is true. So when x is equal to 1, f of x over x is equal to g of 2 over 6. So let's say if we replace the f with the x, with 1, we're going to say f of 1 over 1 is what they're asking about, being equal to g of 2 over 6. F of 1, so f when x is 1 is 5. So it's going to be 5 over 1 is equal to g of 2. So g when x is 2 is going to be 6. So 6 over 6. That is not true because 5 does not equal 1 is what that simplifies to, so nope. Will your SAT book help with the ACT? Yes, it will, but my ACT book is actually, I don't even know if it's out yet because I have to like submit it to Amazon. But it should be like approved to be sold like today or tomorrow. So like I would just wait a day or two, like till later today or tomorrow to get the actual ACT book. So then this, and this is for ACT. So then let's go to number 2. It says when x is equal to -2, are these equal? So again, let's replace the x with -2. So they're asking about g of -2 plus 3. Is that equal to f of -2? So they're asking about g, -2 plus 3 is 1. So they're asking, is g of 1 equal to f at -2? So g of 1, g when x is 1 is 4. So that's going to be 4 is equal to f at -2. So when x is -2, f is 4. That is true. So this is good. And then let's go and check out 3. So 3 is saying g of -1 is equal to negative f of 0. So g of -1. So let's go to -1 for x. That means that g is 3. So we're saying for this one, 3 is equal to negative f of 0. Negative, it's like solving riddles, yeah. Negative f of 0. So negative of what f is when x is 0 is going to be the negative of -3, which is just positive 3. That is true. So it's going to be 2 and 3, J. Okay, let me just block someone real quick. Okay, there we go. Let's keep going. Will the SAT involve circle theorems? Not in the sense that you have to prove them, but yes, it has like the like different rules about circles that you have to remember. So then for this one, and I put a disclaimer on this, like if you're like cramming or something and you don't want a perfect score, just kind of skip this because I can't even remember the last time I saw this on an exam, but this book is meant for cramming and also mastering, like you can tailor it. So that's why this is in here. So then let's go and do this one. So this basically is just a different way of saying find f of g of x, but they'll usually just say find f of g of x. So f of g of x means I'm finding f of g of x is equal to x minus 2. So I'm finding f of x minus 2. So everywhere I see an x, I'm replacing it with x minus 2. So it's going to be x minus 2 times x minus 2, because that's what x minus 2 squared is, minus 1. So then I'm going to FOIL this out. So I'm going to say I have x squared minus 2x plus 4 minus 1. So then we're going to say x squared, combine our like terms of minus 2x, that's negative 4x, plus 4 minus 1. 4 minus 1 is 3, so plus 3. So it's going to be x squared minus 4x plus 3. So it would be f. So then let's go to number 18. So number 18 says, and again, this is the same thing with the disclaimer. This is very rare to be asked, but just in case. So what this says is basically you're multiplying them is what this notation means. So it means you're multiplying the two functions together. So you're doing x squared minus 1 times x minus 2. Can you define what of means in relation to these problems? Yeah, so the way that we read this is like f of x, meaning like people that get confused by that, usually it's better if they think of this as just y equals. So this is basically, when I say f of x, I'm saying what y equals when we plug in x, is what that means. So like if this was f of 1, it's saying what is y equal to when we plug in 1 for x. So what we're going to do here is we're just going to multiply these because that's what this notation means. So these are 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses. So we have to FOIL. FOIL is an acronym that stands for what we multiply. So F stands for the first things we multiply. So it would be x squared times x, which is x cubed. O stands for the outside things we multiply. So negative 2 times x squared is negative 2x squared. I stands for multiply the inside stuff. So negative 1 times x, negative x. L stands for multiplying the last things, negative 1 times negative 2, which is going to be positive 2. So we have this equation right here, which I believe is D. Yeah. So then let's go to number 19. It says, given that h of t is equal to this and g of t is equal to that, which of the following expressions is equivalent to all of this? So again, work inside out. So we're going to start with this inside function. We're going to start with h of 3t minus 9. So Here, they've just replaced what's in the parentheses with 3t minus 9. Well, t is what's in parentheses. So when we're finding h of 3t minus 9, that means that we're replacing the t's with all of this. So instead of writing t over 3, we're writing all of this over 3. So it'd be 3t minus 9 over 3. Now we can divide each of those by 3 to get t minus 3. So now we have that all of this, h of 3t minus 9, is equal to t minus 3. So we can replace all of this in parentheses with t minus 3. And we can say we're finding g of t minus 3. So now, everywhere we see t in this function, we're going to replace it with t minus 3. So this is going to be equal to t minus 3 cubed minus 1. So now I'm just going to expand this out. So it's going to be t minus 3 times t minus 3 times t minus 3 is what t cubed means. It means I'm multiplying the same thing together 3 times. And then what we're going to do is we're going to start by FOILing this right here, because it's 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses. That's going to give us t squared minus 3t minus 3t plus 9. All of that times t minus 3 minus 1. If I combine my like terms, I get t squared minus 6t plus 9 times t minus 3 minus 1. Now I'm going to multiply these. Now this is not 2 terms plus or minus in parentheses times 2 terms plus or minus in parentheses, so this is not FOILing. This is something else where you're actually going to multiply the stuff with the 2 terms, the t minus 3, those are 2 different terms. You multiply each of them times each thing over here. So kind of like distributive property. So we're going to multiply t times each of these, and then we're going to multiply negative 3 times each of these, and combine them all together. So if I do t times all of these, I'm going to get t cubed minus t times negative 6t. Negative 6t times t is negative 6t squared. And then 9 times t is just 9t. And then now I'm going to do the same thing with the negative 3. So negative 3 times t squared is negative 3t squared. And then negative 3 times negative 6t is going to be positive 18t. Negative 3 times 9 is going to be negative 27 minus 1. So now I'm going to combine like terms. So t cubed is not a like term with anything else, so I can just copy that over. I like to cross it out as I'm doing stuff. Someone's asked, do you have any recommendations for a PSAT practice book? A lot of the PSAT is kind of just like the baby SAT. So I would just like typically go for the best SAT prep materials and use that for content, and then just use actual like practice exams for like practicing the timing and pacing and everything. So then now we're going to combine the t squareds right here as like terms. So negative 6t squared minus 3t squared is going to be negative 9t squared. So then I'm going to cross those out so I don't double do it again. So then I'm going to have plus 9t plus 18t. That's going to be plus 27t. Cross those out. And now I have negative 27 minus 1, which is negative 28. So this is my final answer. So I'm looking for that. And that is going to be K right there. Thank you guys for the likes, guys. Use the following information below for the function graphed here. So it's asking, what is the range of f of x? Range is just like what's the highest to the lowest y it can go to. So the lowest y it's going to is right here, negative 1. So it's going from negative 1 to the highest y, which is right here, which is positive 2. So negative 1 to positive 2 would be k. Thank you for sharing and liking the live, guys. So then we have if f of negative 4 is equal to f of a, and a is not equal to negative 4, what is a possible value for a? So first let's find what f of negative 4 is. So this inside the parentheses is what is on your x-axis. So negative 4 is what we should line up on the x-axis. So we should be looking right here at negative 4 and seeing what f of negative 4 is just saying the y. This is saying what is the y at negative 4 when x is equal to negative 4. Well, the y when x is equal to negative 4 is right here. That would be negative 1. Sorry, so then this is equal to negative 1. So now I have to say, okay, what x gives me negative, what other x values give me negative 1 when I look at this graph right here. So -1 for y. So when I look for where's y -1, it's going to be right here and right here. These two little portions there. So it could be any of the x values here or any of the x values here. Hold on, let me get water really quick. So then what we're going to do is we're going to say, okay, what x values do they give us that are possible over here or over here? So this is like -4 to -5, so something between -4 and -5. Well, -9/2 is equal to -4.5. So that works. And then over here, it's saying this would be from 2 to 4, so a number between 2 and 4, or including those. Well, that's not in any of these other ones, so it would only be A. Someone asked a question, what if the range is the height of the function? What is the length of the function called? So if you think about it like that, then the x values, the possible x values, that's the domain. If you're thinking in length terms, I guess. I usually just say the possible x's are domain, possible y's are range. That's how I think about it. The value of x where f of x is at its minimum. So when f of x is at its minimum, we're trying to find the lowest point for the y's. So it's saying which of these x values is this having the lowest y's for. So the lowest y's are going to be, again, here in this piece and here in this piece. So it has to be at what x values? Well, anywhere from -4 to -5, and anywhere over here from 2 to 4. So let's look for those values. Anything from -4 to -5, we don't have that. Anything from 2 to 4, that would be 3, so K. Do they let you use calculators for this in college? It depends on the college class, but this is ACT math, just so you know. In the SAT, do you need to memorize the unit circle? Yeah, sometimes you do. It's rare that you'll need to apply that, but it's possible. So then let's go to number 23, the maximum value for f of x. Okay, so this is going to be referring to the same graph, so let me get this back out. So the maximum value for f of x is, so maximum is where it's the highest, so that would be right here. And it's asking what's the maximum value. Maximum value is asking the y. So they're not asking for the x, they're asking for the y when it's the highest. So it would be right here, the y would be 2, so it's going to be D. Thank you for the likes and shares, guys. Number 24, which of the following is equal to f of -3? So again, this is referring to the same graph, so let's find f of -3 first. That's just asking what is the y value when x is -3. So the y value when x is -3, which would be right here, the y value is 0. So then let's plug that in. So this would be f of, we just said that this is 0. So now we're finding f of 0. So then f of 0 is saying, what is the y when x is 0? So when x is 0, the y is right here, 1. So 1 would be the answer right here. Okay, to hide the comments, I think you just hold the screen and then slide it over, is what people have said in the past. For how many points does f of x equal -3/4? So this is saying at how many times is the y equal to this on the graph? So how many times is the y equal to -3/4? So let's find where y is -3/4 on this. So y being -3/4 would be around here-ish and around here-ish. So that's 2 different points. So that would be 2. So then, is there a link to buy your study material? Yes, if you go to my profile, there's a link to my website, which has if you click on that, the homepage, one of the first buttons is buy my book. And that would be taking you to the SAT one. I'm going to put a link to the ACT one as soon as, later today or tomorrow, whenever Amazon approves it for sale. So then let's go to 26. Given that f is a function defined by f of x is equal to that, which of the following is the vertical asymptote? In my bio, yeah. So in my bio, there's my my website right there. And for how many times are you live? I'm going to be doing this live. We finish in a little bit, but then I'm going to come back at 4 p.m. Eastern. So then let's go to this one. Which of the following is the vertical asymptote? So does the f equal the y? Yeah, that's another way to think about it. Basically, someone in math was just like obnoxious and they were like, we need a different way to say y. But that's exactly the same thing as y. So then which of the following is the vertical asymptote for f? So vertical asymptote just means you set the bottom equal to 0. So this would be 3x minus 1 equals 0. And no, this is not the Barron's book. This is actually my book that I wrote. And then, so now we're going to say, okay, 3x is equal to 1 because I just need to add 1 to each side. So then, let's say that x is equal to 1/3. So then that would be right here. For the person that's like, no, it's a function of x, it's like, yes, technically there's the little like minute differences in like how you say them, but for most students, it's never going to be anything different than like this is, you could just think of as y. And that the inside is x. Like there's very minute like differences in terms of like how you say it and think about it. Like you could literally just think this is y and that the inside is x. So then it's good to know that it's a function of x though. Yeah, but for a lot of students that actually just confuses them further, so they're going to get more wrong if they think about it that way than if they just think of this as y. So then, let's go, and for the problems on the exam, you don't really need to think about it any other way. So, for anyone confused, literally what I say is just, if you're confused with functions, if you don't get functions, think of whatever's in the parentheses as your x, and the outside part, this is just y, is the best way to think about it. So then functions f and g are defined by these. If h of x is equal to g of x minus f of x, then what is h of 3? So let's put h of 3 into this last equation right here. And that is equal to, well, the 3 is your x in each of these cases, so we're going to replace x with 3. So then now what we're going to do is we're going to say, okay, if we want to find h of 3, we have to find what g of 3 is, and then we have to find what f of 3 is and subtract those. So let's find out what f of 3 is. F of 3 is equal to, if we just plug in 3 for x everywhere here, 3 squared minus 3 times 3 plus 2. So then we're going to say 3 squared minus, 3 squared is 9, so 9 minus 9, because 3 times 3 is 9, is just 0, so then that cancels out, and then we're just left with 2. So f of 3 is 2, so we're subtracting 2. Now let's find out what g of 3 is. So g of 3 means we're plugging in 3 everywhere we see x. So we're going to say 3 squared plus 5 times 3 minus 3. And then we're going to say that this is equal to 9 plus 15 minus 3, which 9 plus 15 is just going to be 24. 24 minus 3 is, 24 minus 3 is just 21. So then 21 minus 2. And then we just copy down the h of 3. So that means that h of 3 has to equal whatever 21 minus 2 is. Ooh, that was a bad equal sign. So then that's going to equal 19. So D. Okay, so for number 28, it says the function f of x, this is graphed below. What is the domain of the function f? So domain is just all the possible x values. So right away, you'll see it's kind of tiny to see here, but there's a hole right here at x is equaling -2, meaning that like the reason they can't fill this in or like make it just a line is because it doesn't include that point. Like this is a hole, it's not included, but everything around it on the line is included, but just not that specific place. So we already know that x cannot equal -2 from that. So we can eliminate g just from that because we know that it has to include x is not equal to -2. And we can also eliminate j because that's not saying that x can't be -2. Now, we're doing domain, so we're trying to think what are the x values that are not possible. Well, you'll see here, it's not drawn in, but you'll see that these are all avoiding a number right here. Like they're all getting close to something, but not quite hitting it. and that would be at 5 because that's between the 4 and the 6. So x cannot equal 5 as well. So we need something that says x cannot equal -2 and x cannot equal 5. So that would be this one right here, h. So then let's go to this next one right here. So it says, for the graph of the function below, which of the following is a possible graph for the function? Okay, so for this one, what I would start with is you see how they factor it all out? That's because each of the factors you can think of them as part of your x-intercepts because the factors have to be set equal to 0 to find the x-intercepts. So look at your x-intercepts. So this is -1, 0, and at 2 there has to be an x-intercept, meaning like where it intercepts the x-axis. So what I like to do is I like to think of the opposite needs to be part of the factor. So like -1, the opposite +1 has to be one of the factors. So that means we can cross out e because it has -1. We need the opposite +1 to be one of the factors. We need 0 to be one of the factors, meaning that like on the outside you have to have something with like an x being multiplied by itself because it has to be like each of the factors is set equal to 0. So like this could be set equal to 0 and x would be 0. This could be set equal to 0, x would be 0. This could be set equal to 0 and x would be equal to 0. So we can cross out a. Now the other x-intercept is going to be +2, so we have to say that we're going to look for the negative of that, the opposite, -2. So we can cross out d. So you're basically just looking for the opposite numbers of the x-intercepts in your factors. And that leaves you with b and c. Now remember, on the exam, if you're really stuck, you could just graph this in your calculator, but I'm trying to like show the logical way. And also your calculator could break on exam day, you never know. So it's good to just know this. So now we're determining whether it should be B or C. So then now what we're going to do is we're going to say, okay, I'm going to just test out a point and I'm going to see which of these would work for that. So you could say like, I wouldn't test out 1 because 1 kind of has like funky stuff associated with it. I would test out maybe like something like here, maybe like -1/2. So if I do -1/2, it would be 1/4 times -1/2 times, that would be -1/2 times -2. And you don't even have to solve this. I'm going to show you like what you can do instead. -1/2 plus 1. And then over here, I'm going to do the same thing. I'm going to plug in the same x value, -1. And what I'm going to do is I'm going to see, does one of these turn positive and one of them turn negative? Because it should be negative. So I'm looking for which of these gives me a negative value. So I would say 1/4 times -1/2 squared times, that would be -1/2 minus 2 cubed times -1/2 plus 1. So this is saying we have a negative times, this is going to be a negative value cubed, which is also negative, times a negative, times a positive, because -1/2 plus 1 is going to be a positive number. So negative times a negative is a positive, times a positive is positive. But look, when, oh, sorry, I was meant to say that this was -1/2 right here. When we look at x equaling -1/2, then that should be a negative number, not a positive number. So it can't be b. Sorry about that. I meant to I was talking too much at the same time. This is not what I'm talking about. I'm talking about -1/2 for x right over here. So then when we plug in -1/2 for x over here, let's see, do we get a negative value for our y? Because that's what we should get. Well, let's see. -1/2 times -1/2 is a positive, so this is positive. So we have positive times a positive, and then -1/2 minus 2 is going to be a negative number. Cubed is going to be negative, so positive times a negative, we're at a negative now. -1/2 plus 1 is going to be a positive, so we have positive times a positive, which is just a negative number, which is what this correlates with, so it could be C. Now again, you can just graph this in your calculator if you want to. There's a bunch of different ways to solve this, but typically if you don't understand this, just plugging in numbers and seeing what works is the best strategy. So then let's, oh, actually that's it. So that is it for the functions live right now. If you guys have any questions that I didn't get to while I was doing stuff, put them in the comments. I'm going to stay on for a couple minutes to answer questions, and I'm going to be back at 4 p.m. Eastern time to do another live. So any questions before I head out? Where can I find this document? So this is my ACT book. Let me check if it's on Amazon yet, because I submitted it for approval yesterday, because they have to check before they approve if they can sell it. but my SAT one is already published. Let me see if my ACT one got approved yet. No, it's still in review. But I'll put the link on my homepage once it gets approved on Amazon. But the SAT one is already linked on my homepage. My link to my website's in my profile. And then I'll put the ACT one up when it's available. Let me see. What else do we have? What level math is this? This is ACT math. So this is like something that people usually take in high school to get into college. If you were plugging, how would it work? Plugging in is literally just like what I did here. I just plug in an X value. You can just pick anything and see if it works. Like here I saw that I got, you could like multiply this all out if you wanted to, but I just knew I didn't have to do all that math because I had a negative times a negative and a positive. So negative times a negative is a positive, times a positive is a positive. So if I'm plugging in negative 1/2, this is on the negative part of the y. So I should have gotten a negative number, which doesn't happen here. What is an ACT or an SAT? Those are exams that you take to when you're applying to colleges. Not all colleges require them, but some of them do. What was your ACT score? My ACT score was a 34. Took these math classes in 2010. Damn memories. How far did you go in math in school? I forget what the last math was I took in college. I think it was like called Calc 3 or something. Because I had already taken like both of the I took like both of the APs in high school already. So like I got those requirements out of the way. They let me like use those credits. But then I had like one math credit that I had to do. So I took like the next class for that. And then I was done with my math credits after that. Is college level math harder? I think it's not necessarily harder. It's just that they don't teach you really as much. In college, like you kind of just have to teach yourself. Like if if it was kind of just like a repeat of other stuff that I already learned in my school, so it wasn't hard for me. But like a lot of people struggled in my class because they had never been introduced to it, and it was kind of just expected that you knew it. So that's what's hard about it, not necessarily the content. Bro, I could never do this. I need to learn how to do head dividing. You could do it. It just takes practice. Anybody else have any other questions? Okay. How do you make math more fun to learn? Maybe through application. To make it more fun to learn, I mean, I've always just kind of like seen it as a puzzle, so that's kind of like what I like about it. Trying to think of like how to make it more fun, like incentivizing yourself, like kind of just giving yourself rewards, like basic motivation, like behavior training stuff, like rewarding yourself for good outcomes. I mean, you have the whole like motivation factor of like getting good grades too. Like it kind of becomes more fun then when you see like good results. What is a strong foundation to understand this? What do you mean a strong foundation to understand this? Like, what should you do to understand this kind of math? Practice, 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 practice. Like, follow channels like mine, watch those videos, to kind of like pick up tricks and tips and things like that. I'm literally doing A-level math and I'm still watching this. B, C, D, E are the same. No, they're not. They're not the same. So then, do you love calculus? Yeah, I like calculus a lot too. I mean, I like all math really, except for like physics. Some people consider physics math. I hate physics so much. I just focus on like doing, like people are asking like, can I do derivatives or integrals? I've said over and over, I'll like do that later on my channel because I'm trying to like pick my niche, you know, and like with like the followers I get, like most of them are doing ACT and SAT prep, but like over time I'll add videos on that and stuff. But it doesn't look like we have any more questions. I will see you guys at 4 p.m. Eastern time. Bye.